Hi, in this screencast I'll be showing you a demo of ICE, a tool that is geared towards program comprehension and is handy in situations such as malware analysis and just just as exciting in students trying to understand codes that their prof have given them. So the first step in using ICE is to connect what is known as a data source to it. For this demo, I'll be using IDA Pro, which is a commonly used disassembler, as the data source. So to connect the two, we step over into IDA Pro, and then we run a plugin that I wrote for it that does the communication, or that handles the communication between the two. Once that has been completed, we can go back to ICE, and you'll see now that it asks us to select a tool. So, in ICE, there are currently two tools, and each tool is basically a visualization of the data that is within that program. So the first tool we have is called Tracks, which Jen wrote, and I'm going to skip in this demo only because she's already made some screencasts about them that are really good, and the functionality is the exact same. The second tool that we have is called Cartographer, and we're going to focus on that in this demo. So the first thing you have to do in Cartographer is select the function you want to begin with. So why don't we select the first function that should be called in this program, which is called start. Once you have double-clicked it over on the left, it will, as you saw, it'll open up all pretty in this middle window here. So what we can see already just by looking at this is that start makes three function calls to these three down at the bottom here. And one thing we can also do once we have this is we can dig a little deeper and we can see what calls each of these functions make in turn. So you'll see that we went a little too deep and we have now ended up with nothing that the current function calls. Well, that's okay, because in the bottom here we have the call stack, and along with being able to actually jump back to some previous function, like we'll do in a second, you can also see a bit of information about each of these functions, such as the module it was in, the start address, its name, and if there is a comment associated with it, it'll show up here as well. So let's jump back to the start, and we'll try a different thing. Let's go here, and then we'll go into this function. So now you see we have, again, a whole bunch more calls. So we can actually just kind of continue jumping around all we want, and as you do this, you can build up an idea of what calls what and kind of how things are related within a program. So as you do that, you may come across situations where you want to actually be able to make a comment about something, or about a function, sorry. So let's do that here. So we are currently looking at the reset function, and we want to add a comment about it. So let's just say resets all data. And then we'll hit enter. And once we've done that, notice that in the call stack, the comment that we just entered has now appeared in the bottom. So that's very handy. But we can also, after digging around a bit, you may come across a situation where you want to rename a function as well. So we have this function here called showTarget, which may not be sounding very descriptive, so let's just put, since this is treadmill we're working with, we'll add on the word speed so that it says showTarget speed. And once we've done that, you'll see that the name has been updated in the call graph as well as the call stack. Oh wait, I haven't called it. It would have been updated in the call stack, and also in the top left here in the function list. So a couple other things that are worth noting is that you'll notice that some of the functions are slightly different colors. The nodes are slightly different colors. And the reason for that is that the color is dependent on the size of the function, so the number of instructions within it. So the way it works is the more red color there is, the longer the function is. And the more green color there is, the shorter it is. And the reasoning behind that is that you may want to target really long functions and really dig into what they're doing, or you may want to just kind of identify the short ones and have a quick look at them. So a couple of things that are worth noting that are not shown right now, just because the example I have is a bit simple. One is that external calls will be shown in the call graph, and they will be actually a gray color just so they stand out. And the other is that if a function makes a recursive call to itself, then you'll have multiple arrows showing it, so you'll have kind of a big, pretty graph around it. And the last thing on the similar kind of note is that if you have multiple calls being made by one function into another in the same thing, then you'll have multiple lines being shown. So what you'll be able to tell from that is just kind of how strong the relationship is and basically how many times something is being called. That's a pretty quick demo of the Cartographer, but I think it's a good start, and as I play with it a bit more and better understand what should be there and how it works, I will definitely be posting more videos. I'm going to try and post one where I actually do a bit of a malware analysis with it, so stay tuned for that, and until then, thanks for watching. Bye.